Hello, so I'm just going to make this really quick video. I just have 3 points I want to emphasize regarding IUPAC nomenclature as well as the different types of formula of organic compounds. The first point is that when multiple branches are present, you want to show them in alphabetical order in the name. I don't think I have formally told you this in the original video on naming. I think it might have been listed in the rule, but let's say, for example, if you have a branch here, let's say one here, and maybe let's make this longer, and then you have an ethyl branch. So in this case, if we just follow the normal naming convention, this is an alkane. I'm using skeletal structure. The longest carbon chain is gonna go like this. I think that is longest, so you can have it. So 1, 2, 3, 4, 5, 6. So you have 6 carbon in the longest chain, which is hex, and then you have 2 branches. So this is one, this is a methyl, and you have an ethyl or ethyl. So that's step 3. I need to number my carbon chain, so I'm going to start from this end. So 1, 2, 3, 4, 5, 6. And the last step, when you put the name of the branches into the compound name, we're going to list the name of ethyl first and the position of ethyl first, just because alphabetically E comes before M. And then sometimes I'm like, which letter comes first? Because there are a few other branches that we're going to look at next week. So I thought I just generalize and emphasize this rule again before we have. I think I told somebody yesterday that we're going to have another 9 groups. We're going to have another 8 suffixes and another 8 or maybe 7 prefixes in overall, but I don't think we're doing all of them this year. Okay, so 3 ethyl, 2 methyl, hexane. So E comes for M, so just alphabetical order. That's the first thing I want to point out. The second thing is, and this is a question that I think a few people asked yesterday, which is a very good question, is how can you determine the amount of hydrogen atoms from a skeletal formula? So let's say if we have this, honestly, once you get very good, I show you some other methods later on, but let's just say this is the skeletal formula, and the question is how many hydrogen atoms do you have here? Or maybe the question is, can you draw the structural formula from the skeletal formula? The first thing that you always want to do is you want to draw the actual skeleton out, and the skeleton will show you the carbon atoms that are present in this compound. So I'm just going to go 1, 2, 3, 4, 5, 6, 7. So this corresponds to the longest chain here. So 1, 2. This is not naming. I think if I name, I have to start from this end. 3, 4, 5, 6, 7. Okay. There is a carbon coming off of here. There's one coming off of here. And then there is a double bond between 5 and 6. So this is my skeleton that I have translated from the skeletal formula. And the only other thing that you need to remember is that every carbon atom form 4 covalent bonds. And the reason for this is because carbon has 4 valence electrons, so it needs another 4, so it can have a full shell of 8. And in this particular case, you can use the octet rule to predict how many covalent bonds carbon will form. So it will form 4 always. So you're going to go back in and fill the hydrogen so that every carbon atom has 4 covalent bonds. So this carbon has 1 covalent bond with the other carbon, so it needs 3 more hydrogen. And then there's one here. And then one here. Ooh, okay. 1, 2, 3. I'm actually not. 1, 2, 3. And then you just need to count properly. So this carbon already has 3 covalent bonds, so it just needs 1 more hydrogen. This one needs one more hydrogen, and then 1, 2, and 3. So if you need to translate the skeletal formula to the structural formula, just start with the skeleton and then put the hydrogen in. One more thing that you can use to determine the amount of hydrogen atoms, and that is by using the general formula of the homologous series. So even though this one is not, it's not like one linear chain, there are branches everywhere, it is still an alkene with one double bond. So if it's an alkene with one double bond, and this is the only types of alkene that you're going to look at this year, you're going to look at alkene with multiple double bonds in year 12, but not this year. So if you have alkene with one CC double bond, the general formula is CnH2n. So if you count the number of carbon atoms, not the one the longest chain, all of the carbon atoms, the number of hydrogen atoms should be double that. So I have 9, 7, 8, 9. I have 9 carbon atoms in this molecule, and so the molecular formula of this molecule is C9H18. And if you count this 1, 2, 3, 4, 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, you should also get 18 hydrogen atoms. So using the molecular formula, the general formula of a homologous series will tell you exactly how many hydrogen atoms there are, but you also need to be able to distribute the hydrogen atoms correctly as well. The last thing is something that I missed in the notes. I did update it, but I think everyone have seen it by then, is that condensed formulas should show CC double bond and CC triple bond. This is a new thing that VCE chemistry added. So if you look at condensed formulas in other textbooks or maybe in university, they may not even show this. And the reason why they do that is because sometimes, especially with our experience, it's quite hard to tell just by looking at a condensed formula that something has a CC double bond or a CC triple bond. So they decided that it's easier if they just show it to the students in the condensed formula, and then you want to show it when you write your own condensed formula as well. So I'm just going to maybe go through one or two examples of condensed formula. I think the one thing I want to point out with condensed formulas is that there is more than one possible correct answer when you draw this. And as long as I read it and it makes sense, you would get the mark. So let's say this is a skeleton of this molecule. I probably should do the structural formula to be fair. So let's do that. So 1, 2, 3, 4, 5, 6, and then this one here, 1, 2, 3. There is a double bond between 3 and 4 here, and then the rest is hydrogen. Now I'm just going to do it very quickly so I know exactly how many hydrogen atoms each carbon atom is bonded to. And then there's a H here, that's a CH3, and that's a CH3. So when you write the condensed formula, it really does not matter whether you start from this end or whether you start from this end. You just need to pick a start, and that's fine. So we can start with, let's say if we start with this end. So the first version of condensed formula that I can have here is CH3, and then CH2, and then CH. So show the double bond, so CH, and then CH, and then you can go CH3, CH3. So in the first example, I have used a bracket to show this branch, and that's probably the most unique feature of a condensed formula is you will use brackets whenever you have a branch. And so everything else will be part of the main chain. But another way to write it, so the second correct answer is you can put, so CH3, CH2, CH double bond CH, CH, and then you can, sometimes people put both CH3 in, sorry, that's supposed to be a 2 in the inner brackets as well to show that there are two CH3 coming off of this carbon. You can also start from this end if you want, and that's fine too. So that's condensed formula. I think I do have to go back and fix a few other things. Maybe I should do one more example. Let's do one more when it's not exciting whatsoever. So let's do that. So okay, CH3. There are 3 hydrogen here. Oh, I have to do the I have to do the, well, this is not structural formula, this is semi. 1 2 3 4 1 2 3 4 5 6. I don't know why I did this. 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7 8 9. Okay, there's a double bond here, so H2 H2 H2. That's not good. Let's try this again. Okay, so when you have multiple CH2, which is the reason why I say this, you could put that in a bracket. That's another use of bracket. I know I just said, oh, you can use it for branch, but if you it's a CH2 and then 1 2 3 4 5 6 6, if you write this, it means that it is part of the main chain. Just repeat itself 6 times, and then you can go CH2. So this particular condensed form, it's really short to write, which is pretty good. But anyway, that's it. Only 3 points.